Good morning, dear students. In last class, we discussed the method of variation of parameters. Now we will discuss the next method that is called as Cauchy's Legendre homogeneous equations. Uh, Cauchy's is different and Legendre is different. We will get two types of examples in examinations. So definitely you will see the question of Cauchy's and Legendre. Okay, so let us discuss Cauchy's homogeneous equations. So how it is, let us discuss here. I have given a notes for you. Cauchy's linear equation is given in the form of like this. The Cauchy's homogeneous linear equations of second order is given by. You will get this is the first time this type of equations, that is with having coefficients, constant coefficients a naught x square y double dash. Compulsory it should be x square y double dash. That means if it is a power double dash, second order is there, the power of x should be 2. Similarly, a1 constant, second constant, x y dash is plus a2 y is equal to phi of x is equal. We called as this as equation 1. If you get this type of equation, these are known as Cauchy's linear equations. Cauchy's homogeneous linear equations. If it is like this, you put directly that log x is equal to t. Then again you transfer this log to this side, it become e raised to t. That like this, e raised to t x is equal to x. Then after getting this one, and we have some formulas regarding this one, that is x y dash. In the differential equation it is there. If it is like this, you need to substitute dy. Then x square y double dash d into d minus 1 y. X cube y triple dash d into d minus 1 d minus 2 of y. So on. Right? Equation 1 becomes, that means the equation 1, you need to substitute these all values in this equation 1. Then you will get this type of equations, right? And you need to substitute log x is equal to t also. So therefore substitution of this one in LHS, it become like this, and is equal to the expression for phi of x changes from like this, phi of e raised to t. X means e raised to t. This is phi as it is, and here phi of x is there. X substitution, x is nothing but e raised to t. Okay, then this expression we generally denoted by f of t. This is general form. Okay, then you will get f of d of y is equal to f of t. Then after getting this one, this is exactly the homogeneous differential non-homogeneous differential equation, right? And you know how to evaluate this one. That comes under type 1, type 2, type 3. If it is exponential, type 1. If it is a trigonometry, type 2. If it is in a polynomial in x, type 3. Then go on solving the equation, that is y is equal to general solution, y is equal to yc plus yp, as we did in the type 1, 2, 3, 4. Okay, then similarly let us discuss one example. Example is like this. Solve the equation x square d square y upon x square minus 3x dy upon dx plus 4y is equal to 1 plus x the whole square. First, what you have to do is that you have to write down in the form of Cauchy's Legendre differential equation. You see here, the coefficient of d square y upon dx square, if it is having x square terms, square x terms, so therefore it comes under Cauchy's differential equation. Then if it is like this, you have to write down this equation like this also. X square first, then this expression is denoted by y double dash minus 3x. I have did here mistake, so let us write down it. 3x y dash plus 4 is equal to 1 plus x the whole square, and called as this is equation 1. In this equation 1, you need to substitute, that is log x is equal to t. This is if it is Cauchy's, you need to put the value of log x is equal to t. Then transfer this log to this side, it becomes e raised to t is equal to x. Then use these all values and use these formulas also, x y dash and x square y dash, because this examples contain x y double dash and x y dash. So therefore you need to substitute these two values. Substitute these two values in equation 1 and you will get like this. The first term is x square y dash, so therefore d into d minus 1. d into d minus 1. I have taken y outside. Then similarly substitute x y dash as d of y, that is d of y. Here it is 3 having, so d of y is written d of y plus 4 as it is of y is equal to, and here it is very important, here instead of this 1 plus x, 1 as it is, substitute x value is nothing but e raised to t. In this equation you will get like this, that is 1 plus instead of x e raised to t whole square. Then you will simplify this one, multiply d square d, then 3d plus 4 as it is, then expand a plus b whole square, a square plus b square plus 2 times ab, right? A square plus b square plus 2 times ab. So therefore you will get like this, this is like this is exactly like this, look like f of d of y is equal to phi of x. Here it is in the form of t, so let us write down in the form of t. And after getting this type of equations, now you go for the type 1 2 3 example. You see this example, this is f of d of y is equal to phi of t. So exactly here it is having from LHS you calculate YC, and from RHS you calculate YP. Okay, then go for auxiliary equation. Auxiliary equation, you know that, replace d as m, so m square minus 4m plus 4 is equal to 0. Using calculators, get the roots for m is equal to you got in this example m is equal to 2, same roots are there, you know how to write down the complementary function, so therefore this is complementary. Half of the example is over. Now let us discuss the particular integral for the this example, that is calculated from the RHS. So you see here, here constant term is there, here exponential, here also exponential. The total, these all three having p1 p2 p3, three particular integrals, so you calculate separately particular integrals. So first one is exponential type, second one is also exponential type, third one is also exponential, because you can convert this constant into exponential as I told you in the first type of the example. So therefore you can write like this, this can be yp can be calculated like this, yp is equal to phi of x divided by f of d. You know this is general form of the formula for the particular integral. So phi of x is this one, I have written this one in the numerator, and divided by f of d. F of d is common LCM for all the three terms, I have taken separately. Now you separately calculate the particular integral. So let us write down here. This can be written in the exponential form, this is as it is, this is as it is. Now you know that replacement in the first type of the example is, replacement is d as 0. This can be taken as coefficient of the exponential coefficient t is 0. So similarly exponential 1, here to substitute, if you will get here 1, this is e raised to 0 is nothing but 1 only, this 0 0 4 remains. So similarly here replace 1 1, you will get as 1 here. Then when you go for the second last one, that is substitute here d as 2 square 4, here 4 2s are 8, 4 4 8 8 minus this I have written here 0. So if it is getting a 0 in the denominator, as I told you in the type number 1, that 1 or 2, so I told you the first two terms as it is you got the solution, but while in the case of third one you got 0 in the denominator, what you have to do is that, so differentiate the new denominator and multiply here with t, because you are here you are having a variable is t, therefore you have to multiply with t and differentiate the denominator, so to get the solution. So t, multiplying t and differentiating the denominator, you got like this. Again you need to substitute d as 2 only, you got again a 0, that means denominator becomes 0. Again you have to differentiate this denominator and multiply with again t here, so you will get here t square, and differentiation of 2d is 2. Then after getting this, you see here you got the solution here, so this is known as yp. This yp, then totally general solution is given by y is equal to yc plus yp. Then y is equal to, you write down yc and you write down yp. At the end you need to substitute the value of t, so I have not written here, let us write down here, y is equal to c1 plus c2, log x is equal to t is there, so you need to substitute here log x, right? E raised to 2t, this can be written as e raised to t, as I told you e raised to t is nothing but x, so this can be written as x square, okay, plus 1 divided by 4 plus 2 times e raised to t is nothing but x plus t is nothing but t is nothing but log x, so therefore you can write here log x e raised to 2 is nothing but x square divided by 2. Okay, so this is an example I have taken. Now let us discuss, you see the other examples, you get to know by using this video. Then one more example is there, little bit different example is there. You go through this example number 4, solve this equation by Cauchy's form, right? You see, as I told you, the if it is having d cube y upon dx cube here, d cube y upon dx cube, the coefficient of this should be x cube only, then only you can write the formula for this one. But you got this type of equation. To make this x cube, you need to multiply x square here. So therefore multiplying by x square, we get x cube y triple dash by x square y double dash. If you multiply x square here, so you will get cancel here 1x, here 1x get cancel, you got 1. Then equation 1. Then you solve further as I told in the video. Okay, I hope you understand this one. Go through this. Okay, you will get the solutions of all the examples first. Okay, thank you.